Hello, everyone, and welcome to our Sustainable House Day expert session. We're so glad you could join us tonight. First, I would like to acknowledge that we are meeting today on the stolen lands of many First Nations peoples. I am speaking to you from the lands of the Wurundjeri people of the Kulin Nation. We would like to acknowledge their elders, past, present, and emerging. Sovereignty was never ceded, always was, always will be Aboriginal land. If you'd like, feel free to share which Aboriginal land you're joining us from in the chat. Before the webinar begins, I would like to tell you a little bit about Sustainable House Day and Renew. So Sustainable House Day is a national event that gives you access to Australia's most sustainable homes. This year, we're offering 4 themed weeks of online and in-person events around the country leading up to Sustainable House Day, which is this Sunday, October 17th, when we will host a day of free online sessions with homeowners. This week is our Climate Resilient Homes Week, and you can see our website for other events that we have this week. You can visit sustainablehouseday.com to see detailed house profiles and tour videos for the 130 homes open this year and to book for our upcoming events. Sustainable House Day is organized by Renew, a not-for-profit that inspires, enables, and advocates for people to live sustainably in their homes and communities. You can find out more about us at renew.org.au. Tonight's session will begin with expert presentations and presentations by some of our Sustainable House Day homeowners, and then move on to a Q&A session. You can ask questions at any point in the webinar this evening using Zoom's Q&A function, which you can find in the toolbar at the bottom of your screen. Please use the Q&A and not the chat to ask questions. We also have live closed captioning for this event. To use it, you can click on live custom live streaming service in the upper left-hand corner of your Zoom window, and then click view stream to see the automated captioning in a browser window. So that's it for me. Now I would like to hand over to our MC for this meeting and a member of the Renew board, Michael O'Connell.
Thank you, Sophie. Welcome, everybody, to this, what promises to be a really, really interesting webinar this evening. We've got a number of really brilliant presenters today, all talking about water. For those people who don't know me, my name is Mike O'Connell. I've been a long-standing member of Renew and formerly ATA, of course. Currently on the committee, as Sophie just said, but I've also got a very strong focus on sustainability. I've got a permaculture garden, do a lot of work I've got some interest in water since I have a 25,000 litre tank out in the backyard that we use. But more importantly than me are the presenters this evening. We've got 3 presenters and then a 4th person who we're lucky enough to have with us for the Q&A session as the panelists later on. The first person we're going to have up is Dennis Doon. He's going to be talking about all things water related, water diverters and a whole range of interesting topics. The second speaker will be Margaret Moskowska, sorry, and she's from the Moss House Edible Garden in New South Wales, located on a steep hill. Moss House Garden is an example of a 13-year-old vibrant, sustainable permaculture property designed with primary goal to provide owners with food, medicine, and fibre plants. And she's going to give us a very interesting talk indeed. Roman Spur from Spurtopia is aiming to be self-sufficient, as we all are, or many of us are, energy, food, water, and waste-free, to showcase the home for people to come and be inspired. So applying a clever design, the ideas, inventions, engineering, using readily available materials, and they make the place an outstanding with continuous improvement. So they passionately like to share practical and inexpensive ideas for sustainable living. And there'll be links available afterwards for that. And then finally, we have Eric Brocken, who's from the Hawkesbury Earth Care Centre in New South Wales, it's another Renew facility that we have out there at the university. And Eric's been involved in that for many years. The Earth Care building itself utilises passive solar design and a variety of building materials and techniques to demonstrate sustainability options in domestic and commercial construction. Walls of rammed earth, mud brick and straw bale. So as you can see, we've got an amazing number of people. Each presentation will go for roughly 20 minutes. Once we have all the presentations, we'll open up to the panel, and then we'll actually field some of your questions. And so the questions can be coming in and they'll be curated, and we'll see if we can get through as many questions as we can. So first up, we're going to have Dennis, and he'll be talking about a lot of water diversion techniques and a whole lot of other technologies and other actions around the house. So it's over to you, Dennis.
My talk today is about rainwater harvesting best practice and how to recognise endemic substandard practices. It's the substandard endemic practices that stop people fully utilising their harvested resource, either by not wanting to use dirty rainwater in a toilet system or to wash their clothes. Best practice is the delivery of good quality water to the tank and the delivery of the best quality water in the tank to the pump with minimal maintenance and good utilisation. Best practice is easy to achieve, and quite often it costs a lot less than what people are used to getting now. Now, I am going to talk about utilisation straight away before we go into best practice and how to achieve it. So we have to assume here that we're using good quality water. And the slides on the screen show a fluid master system valve and a toilet system with two system valves, one connected to rainwater, one connected to mains water. Now this is a manual system. Most people have automatic mains water systems. It's a choice. Automatic mains water system switches over to mains water when the water level in the tank gets low, but they cost a lot more. Mains water switching devices are expensive. The rainwater is diverted into the house pipe, and consequently the house pipe has to have a check valve. The manual system is simply a matter of closing a valve for either the mains water or the tank water and opening the other. You can have the valves outside. This particular system I'm about to talk about has two isolation valves on the toilet wall. You have the normal mains water isolation valve plus an additional isolation valve for the rainwater. One will be open, one will be closed. You don't have to go outside to open and closed valves if all of a sudden your rainwater, your pump stops pumping rainwater because the rainwater level in the tank gets low. This particular system in the diagram is connected, the rainwater tap is connected directly to the pump. It's not connected to the house pipe. It just comes directly from the pump through the wall and connected directly to the system valve. The air gap at the top of the system valves prevents any cross-contamination. This is by far the cheapest way to plumb rainwater to a tank. No mains water switching devices. You've got the two taps. That's all you need. Now, if you use a system valve made by Fluid Master, and the model number is 400 UK063. It's a very compact valve, very compact. Cost about $20 in Bunnings. But it has a huge advantage. There are two optional valves. There's a low pressure valve and there's a red valve, coloured red. It's a low pressure valve, gravity fed. It's part number is 242LP071. Now that allows you to bypass the pump, turn the pump off, and let water from a tank gravity feed and fill a cistern valve, provided you have 1 metre of head in the tank. Now I found on my cistern, I can go down to 700 mil of head, and there's enough pressure for it to close the seal. On my system, the pump is off for about 8 months of the year. Now I do use the pump at other times during the time it's off, and you wouldn't have the pump off for that long anyway. But that cuts down on a lot of pump stop-starts, pump supplying rainwaters to a system use. But they have a tremendous number of stop-starts during the year, short duration stop-starts during the year. And the manual system I've just described, you're actually allowed to do it yourself. Be very careful if you drill a hole through the wall. If you don't use a plumber, all you're up for is a cistern valve, $20, isolation valve, bit of PEX pipe. You can do it for under $100. Now on the next screen, on the next slide, we'll talk about how to option a tank. Now, most people, when they option a tank, they might think of the size, they might think of the colour. There's a lot they don't think of, and there's a lot they're not told about. For example, the top left photo, it shows a very high fitted overflow pipe. Now, overflow pipes have mesh, and that mesh can block. So for maintenance, you either have to take the pipe off on the outside or remove the top meshed inlet and clean the mesh via the top meshed inlet. The photo, the top left photo, shows the inlet a long way from the tank. You wouldn't be able to clean the mesh. But the photo also shows something else. The overflow pipe is fitted very high, very high. Overflow pipes flow faster the higher the water level is. And horizontal overflow pipes are very inefficient. Now I've got a few just consulting a few figures here. Well, firstly, most overflow pipes are 90 mil. The actual area through the mesh is 84 mil. A 90 mil overflow pipe, stormwater pipe, actually has an internal diameter of 86.2 mil. And you also lose other the area of a flow path is further reduced by a build-up of whatever they put around the mesh on the outside. It reduces it to about 84 square mil. Now, I don't have figures for 84 square mil pipe, but I've got figures here for a 100 mil pipe, and it's off AS 3500.1, section 8, and it lists the flow in litres per second the different size pipes with different heights of level, different water levels, heights of water. Now, a 100 mil pipe, I'll quote the 100 mil pipe, a horizontal pipe with only a 20 mil height of water above the invert that inverts the bottom of the pipe, flows at 0.26 litres per second. Now compare that to a pipe, a vertical pipe. A vertical pipe with 20 mil height, this is a 100 mil pipe, will flow at 1.77 litres per second compared to 0.26. The 100 mil pipe with 100 mil of water above the invert. The horizontal pipe will flow at 4.67 litres per second versus 6.6 litres per second for the vertical pipe. But there's one big difference between these figures and what's in most rainwater tanks. These figures are for unmeshed pipes. The mesh typically has an open area of about 55%. Now, if that was flat mesh, there would be a sizable restriction. But because the wire mesh is bell mouth, it's round, so it's bell mouth, a 55% open area would give about a 20% reduction in flow rate. Now, I haven't tested this, it's something I do want to do in time, but I would expect at least a 20% reduction in flow rate because of the restriction presented by the mesh. Now that top left photo, that overflow pipe has no mitigation whatsoever. You need mitigation on a tank. So you can have increased water level above the pipe. The higher the water level, the faster the downpipe will overflow. But there's a trend now for round tanks to have the overflow in the roof. If you look at the photo in the top left, the top right, the overflow is higher than the bottom of the mesh. There's just no mitigation whatsoever, absolutely no mitigation. And people, they have wet systems that harvest 2, 3, 4 downpipes plus the downpipe near the tank. They're getting plenty of water as soon as they the flow. Two lessons to be learned here. If you look at getting a round tank, don't get one with the overflows right at the top because you won't have much overflow capacity. And if you have a slimline tank, don't put it right at the top. You can if you maybe only have 1 or 2 downpipes going to it, but if you have several downpipes, don't have the overflow right at the top of the tank. Now, I said before about overflow mesh clogging up and how do you access it. I mentioned that maintenance, you need to either take the overflow pipe off or get to it through the tank's inlet. And under those 2 tanks we have an overflow mesh that was completely blocked and after it was cleaned. Now I answered this on one of the forums and the person didn't know why their tank was overflowing. And you had to take the pipe off from the outside in order to get to the mesh. Now he ended up, at my suggestion, fit in what's called an air gap. Now that's in the bottom left, and these are made by the rain harvesting company. The rain harvesting company make both those products in the bottom left. Now, an air gap goes into the downpipe. It has a mesh at the top and at the bottom, and it's a great product. I think it's Rainwater Harvesting's best product. It's certainly my favourite of what they have. Now, if you have that, you don't need to maintain the mesh at the top of the overflow pipe because you can remove it. You don't need it. The air gap has two meshes in it, top and bottom. So this doesn't only cut down on maintenance, it also increases the overflow capacity. Now, the middle photo at the bottom, that's called a high inlet, a high overflow outlet, sorry. And what it is, what you see there is inside the tank. That upturned bit is inside the tank. Now, it's only advertised as a high overflow outlet to increase the storage capacity of the tank. Rain harvesting in their instructions state quite strongly that the top of it, the weir, has to be below the mesh in the top inlet. I've come across people who have fitted these and the water level in the tank is above the top mesh, the top inlet's mesh. This is a great product, but I would use it to increase the overflow capacity of the tank. If you fit this, you have to be very careful about the mitigation of the tank. You can't have it too high. Now, I gave a few figures before about how much more efficient a vertical pipe is draining than a horizontal pipe. If you use this as the drain with the overflow pipe going down on the left, it becomes a vertical pipe, much, much, much more efficient than a horizontal pipe. But you won't have it right at the top of the tank. You'd have it down a bit so that you can harvest a lot more water and not worry about overflows. If you're on the land and you have a huge tank, now they have huge overflow pipes. Quite often, or more often than not, they'll have a bell mouth fitted to the top of the inverted elbow. And that increased diameter allows a lot more water to drain. So it's a vertical inlet and it's a lot bigger. Not practical to have a bell mouth on the fitting at the bottom middle because it has to go through the hole. You'd have to put the bell mouth through on the other side. But if you get rid of the overflow mesh, fit an air gap and fit that inverted elbow, then you'll have a very high overflow capacity. Now, in the next slide, well, we see a inlet, a lot of rubbish on it. a lot of vegetation, and vegetation grows pretty quickly actually once the mesh clogs up. You can buy commercial products, a screen that goes above the mesh, or you can just get some shade cloth. Just cut out a round piece of shade cloth, oversize it, so you can put a couple of stones or something around it to anchor it down. Although most time they don't need anchoring, they don't seem to fly out with the wind for some reason. And you won't have all that vegetation. But it's important to constantly check it and to have something other than the mesh, have something over the mesh, whether it's a commercial product or shade cloth, is a good idea. The other thing you have to look for when you option a tank is make sure that the valve that supplies the pump isn't on the bottom of the tank, as most are. The worst quality water in the tank is the high density water that settles on the bottom. It's low in oxygen, and that's also where the sediment layer is. You don't want a pump drawing water next to the sediment layer. That valve at the bottom left is a drain valve. Now, we'll be doing a new website early in the new year, and I'll be detailing a DIY tank cleaning kit you can fit to a low drain valve. Very simple to do. All you do before you connect the drain valve, now the drain valve's connected before the boiler gate valve's fitted, you connect a flexible pipe on the inside and connect that to a T, generally a faucet T. A faucet T has a female thread in the branch. You have a couple of PVC pipes coming out of the runs, so you have two PVC pipes. You can bend PVC pipes, gently bend them, not too much, but you can use a hairdryer or a heat gun and slowly bend them, and there's a couple of other ways of bending them. You can check YouTube on how to bend the pipe. You'd use a small tank, you'd have a 25mm outlet valve, a bigger tank, maybe 5,000 litre tank or something like that. You could go to a 32mm valve or a slimline tank, go to a 32mm valve. So you've got on the inside a flexible hose going to a faucet T with pipes coming out of the runs. There'll be caps on the end of the pipes, and instead of drilling holes about 120, 130 degrees down the side of the pipe, that is more than halfway between top and bottom on the bottom side, you drill slots. Slots are much more efficient than holes. Drill slots about 4mm wide, regularly spaced, and when the tank's full and you're expecting rain, just open up the valve and you'll suction clean the bottom sediment layer. Very easy to do, quite cheap to do. The parts don't cost much. The parts will probably cost less than $20 for sure. On the right-hand side, one thing I forgot to mention about the pipes, you have to calculate the cross-sectional area, the total cross-sectional area of the pipes, of the slots, sorry. You don't want the total cross-sectional areas of those slots or holes if you can't be bothered cutting out slots. You don't want the total cross-sectional area to be more than double the cross-sectional area of the pipe itself. If you have too many holes or slots, you won't get the suction. Now on the photo in the bottom right, we can see a pump that's draining from a drain valve. Not the best. But it's another thing we also see. We see copper pipe being used. Rainwater is naturally acidic and it reacts against copper pipe. Most rainwater is about 5.5 pH, but during thunderstorms it can get below 4 pH. 3.5 in a thunderstorm is not uncommon, but mainly up in Darwin, places like that. So you don't want to be using copper pipe with rainwater, particularly if the water stays in the copper pipe, if you go away on holidays or something like that. It's not a good idea. Now, another thing to look out for with the pump is the connection to the suction side. A lot of plumbers connect a pipe to a 90-degree elbow on the suction side. Not a good idea, not a good idea. There should be a straight length of pipe that respects at least a minimum 5 internal diameters. I'd recommend 8 internal diameters. So if you've got a 25mm internal diameter pipe, you'd want a 200mm straight length of pipe before the suction side. Another thing is 25mm blue stripe poly pipe is a common hose to use between the tank outlet and the pump. Blue stripe poly is measured as an outside diameter, and the most commonly used 25mm blue stripe poly for pumps is PN12. That has an internal diameter of about 21mm. Now, going from 25 to 21mm might not sound a lot, but it's about, I think it's about 42% of a true 25mm hose internal diameter is about 42% from memory, bigger than a 21mm. In some pumps, they specify in the warranty that you have to use a pipe or hose that has the same internal diameter as the pump's suction port. But if you've got a pump and it's a fair way from the tank, then you really do need a 25mm diameter, internal diameter pipe, and not a 21mm internal diameter pipe. This next page shows a tank with a cover. Now, under that cover is a mains water switching device. Now, this is very clever. It's neat. There's no box on the wall. There's a submersible pump under it, which supplies water to the mains water switching device. It's a clever device. I just want to draw attention to the 2 copper pipes. Now, one of those copper pipes is bringing mains water to the mains water switching device, but the other copper pipe goes into the house. And a lot of the time, that will have rainwater in it. Again, it's not a good idea to have copper pipe with high acidic rainwater. Rainwater is naturally acidic. On the left of the tank, receive a top meshed inlet. And we also see the downpipe, so this will be a new installation. Now, we also see the overflow pipe fitted. Now, when that downpipe's connected and pushing water into the tank, diverting water into the tank, just think of where the direction of that water. It's going over to where that submersible pump is. So the water will be falling at a height. And when the water level in the tank is close to empty, that water will be falling down at a height all around the pump on the sediment layer. Not a good idea. Not a good idea. The bottom left pump is a submersible pump. And this is a submersible pump that draws water in from the bottom. Numerous pumps like this are installed just by plunking the pump on the bottom of the tank. The worst possible place you can put it, because all it will do is vacuum the floor of the tank, as can be seen in the photo in the right. Now, apart from dirty water going through a submersible pump, now submersible pumps can take a bit of dirty water, but you're sending dirty water to the system or to your washing machine. And depending on when you send it, how long after rainfall and how much water in the tank, that reflects on the quality of the water going into the tank. If a submersible pump draws water from the bottom of the pump, it should be on a stand, and a stand higher than that one shown in the left-hand photo at the bottom. Because most people don't de-sludge their tanks. And also, after rain, even a day or so later, the water at the bottom of the tank is still fairly turbid. So you want to pump up a good distance off the sediment layer. Now the next slide, we've got dry and wet systems. I'm just going to go over dry systems very quickly. A dry system is a downpipe that feeds the tank through the top inlet. It's a downpipe that's very close to the tank. So when it stops raining, there's no water left in the downpipe. That's why it's called a dry system. Now, the negatives on the dry system is that you can only harvest one downpipe unless you run other dry downpipes along the wall, which is ugly. Some people do it, but it's ugly. Now I'm going to go straight on to wet systems. Wet systems, they allow additional downpipes to be harvested. You can harvest another 2, 3, 4, how many you like. But they have problems. These problems can be overcome though. We'll go into that later. One of the biggest problems with wet systems is the diagram you see. This was, I originally saw this on the Victorian Plumbing Industry Commission website, and I complained about it then. And when the Plumbing Industry Commission was abolished and became the Victorian Building BVA, Victorian Building Authority, which incorporated building and plumbing, they also adopted it. And other regulatory bodies in other states also adopted it. It's a terrible diagram that's caused a lot of trouble. You'll see above the vertical riser, that's the pipe that goes up the side of the tank and pushes water, or water is pushed from a higher elevation into the tank. It's got 300 mil. Now that's led to a widespread belief that as long as you have 300 mil head of water, that's all you need, 300 mil head. Nothing could be further from the truth. The head you require has to be hydraulically calculated. Otherwise, you'll get tanks overflowing. The length of a pipe, the size of a pipe, your roof area, and the area you're in, your rainfall intensity determines how much head you have. The other thing that was wrong with this diagram was that if you look at the overflow pipe, it states size of overflow equal to size of stormwater charge pipe. Terrible information. A stormwater charge pipe can be servicing 3, 4, or 5 downpipes, plus there could be another downpipe next to the tank. And we've already talked about the mesh at the top of the tank, at the top of the overflow, sorry. The overflow pipe has to be calculated to be either equal to or greater the capacity of the inflow capacity. Numerous downpipes are inadequate and tanks overflow. Plus, it's not only the mesh causing the obstruction, it's when they clog up. And again, I can strongly stress to people, get rid of a mesh, fit an air gap. It's a great product. And fit the overflow a little bit lower and put that other fitting in with the elbow that becomes a vertical pipe inside the tank. But this particular diagram has really caused a lot of problems. And it's just become an old wives' tale that you only need a 300 mil head. It's just rubbish. Now, the other thing about wet systems is that the pipes are underground. Unless you have a discharge valve coming off that wet system that's lower than the underground pipe, the pipes retain water even when you flush them. So there is a way to get around this. We'll discuss this shortly. And having the leaf diverter as shown up near the gutter, it's a good idea. But the only leaf diverter I recommend is the Icon. It's called the leaf and debris controller. It has a flat mesh. It doesn't hold water. Nothing worse than a leaf diverter that retains water inside it. And the flat mesh just lets things slip off. It's not mosquito-proof mesh on the outside. It's got a big mosquito-proof mesh on the inside. And maintenance is really good. Now, Aquatrek actually has a new leaf diverter. We've been working on it for quite some time, but we can't manufacture the filter with plastic moulding, but we're going to try 3D printing, and it will be far superior to anything that's currently on the market. Let's just hope that we can get it out there. I don't want to downgrade the filter any. It's been a lot of work put into the filter. We'll have 500 micron filtration and be quite small, extremely efficient. Now, next slide. We have a slimline tank with a vertical riser. Now, there's a few things about this photo. This is typical, very typical. Firstly, on the wall, you can see a couple of copper pipes, 2 copper pipes. That wasn't the purpose of putting this photo. I only noticed that late in the piece. The vertical riser at the top shouldn't be that high. It should go over and be horizontal and have a flap valve on it to stop mosquitoes breeding in the pipe. Mosquitoes can access that pipe, the standing water in that pipe. Now, this slide says first flush diverter. What is its purpose? Well, a first flush diverter collects the first dirty roof wash, the most polluted water off the roof. Comes down the downpipe into the tank. But what you see here with a vertical riser with a first flush diverter fitted to it is typical of new home installations and way a lot of plumbers fit them to existing properties. Now let's just think about it. When it stops raining, the wet system retains water. It retains water. If that first flush diverter wasn't there, it would retain water to the level of that top elbow. The first flush diverter is there, so it only retain water to the invert of where the first flush diverter joins the vertical riser. Now all that pipe, that wet system, the vertical riser all the way underground and the downpipes to the same level is full of water. The first flush is washed down the gutters into the downpipe, and what goes into the first flush diverter is the settled water that's in that vertical riser. The first flush is still back in the downpipe. Yet this is the way just about every single house, new house, has their rainwater tank installed. Absolutely useless. The first flush will still go into the tank. That's not doing its job, and it's a waste of money. And no one's woken up to it. The other thing we see on this pipe, on the at the bottom of the vertical riser, is what's called an IO, inspection outlet. It's a round cap. Now that's supposed to drain the first flush, the wet system. Now when you open that up, the head of water that pushes water out of it, it will drain out of the vertical riser, but what's in the underground pipe, what pushes that water is the number of downpipes and the amount of water in those downpipes. You cannot properly drain a wet system with an above ground inspection outlet. It just doesn't work. You need a flush outlet that's the same or either the same level or slightly lower than the underground pipe. The dripper on the first flush diverter, these are a real trap because they drip at about 4 to 6 litres an hour, some more. If you see the water coming out in a steady stream, it'll be more than 6 litres an hour. 1 drop a second is 13.5 litres in 24 hours. That's 1 drop a second. 13.5 litres every 24 hours. So a steady stream of water is very, 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 very wasteful, because that's coming out during the entire rain event. A manual first flush diverter is much, much, much better. And you can set a manual first flush diverter with a dripper if you want it, when you go away on holidays or whatever. Next slide. Now I'm just going to mention downpipe adapters. These are at the bottom of downpipes where they join the stormwater. They present an obstruction. They're actually not compliant, because if you had that obstruction in the downpipe wouldn't be legal. But what I've put this up for is to just demonstrate that the water, the path of water going to the stormwater pipe is smaller than the downpipe. Now, there's a few reasons I want to mention this. I don't want to spend too much time on it, even though it's extremely important. Roof water harvest, downpipe sizes have their own regulations, and they're based on a 1 in 20 year storm event. Stormwater pipe is based on a 1 in 100 year storm event. And the stormwater pipes also accept water off surface drainage and ag pipe drainage. Now, rainwater harvesting doesn't have its own regulation. If you use stormwater pipe, the water coming down a downpipe at the head of a wet system, it builds up sediment at the head of a wet system. So for rainwater harvesting, flushing is very important. If rainwater harvesting had its own regulations for the pipe size, you would have different size pipes than you would for stormwater harvesting. Not sure if I've explained that right, but for rainwater harvesting, the flushing velocity through the pipe is important, really important. And I'll get back to that later on, because I've got something that can really improve the quality of water going to a tank through a wet system. This next slide shows what we call a low restriction inlet. Water going into a tank has to pass through mosquito-proof mesh. But if you have leaf diverters, you can divert that water directly into the tank because it's already passed through mosquito-proof mesh. Now, a low restriction inlet is a good idea to use with a wet system. It can just come off, instead of having an elbow at the bottom of the vertical riser, you could have a T, and the extra outlet can go to the low restriction inlet. And the low restriction inlet supplements the head on a wet system. The vertical riser always has the same head at the top of a tank. A low restriction inlet reacts to the height of the water in the tank, and it will always have priority fill over the vertical riser, because the water level in the tank will always be lower than the water in the vertical riser. An additional benefit is that the water left in the wet system, in the vertical riser, and in the downpipes will be the same level as the water level in the tank, and not the level of the vertical riser above the tank. Next slide. Now what we have here is something that we developed during our super diverter research and development program. It's extremely effective. Now, the bottom one is actually one that a person I answered questions on the Home One forums. It's the one that she did, following my instructions, and she drew the diagram for me. She's used the same size outlet pipe, which rises above the surface, whereas the one at the top is our standard one that we show people. And we've adapted it to a 100 mil DWV pipe in the top diagram. Now, how it works is sediment, floating sediment, suspended sediment in a wet system settles as bed load. Now, we have a sediment trap. All it is either a upside down Y junction or a T. A Y junction has a bigger hole. The bed load moves very slow. Most of the time it's stationary, but it will move along every now and again. When it comes to the hole, it just falls down the hole and it goes into a elbow at the bottom. Now I've got a pipe reducer shown there. We now use an invert taper because it's a smoother flow path through, and the pipe reducer did hold back a little bit of debris on the lip at the bottom. We reduced the size of the pipe, and we have an outlet valve above ground that flushes out the sediment that's been collected. Now, reduce the size of the pipe to save water and also to increase the velocity of the water through that smaller pipe. This is very, very, very effective for wet systems. But you have to have it in a section of pipe at least 3 or 4 metres past the last point of turbulence, which would be a T or an elbow. Very, very, very easy to make. You just go down every few weeks, once a month, whatever, open up the valve, you'll see a slug of black water come out, then it'll go clear again, and that's all you do. But this saves a lot of sediment from going into a tank. Now, the one at the bottom There was a wet system going to a tank, but there was a major problem with the way the plumber did the wet system, and there was a lot of crud still in the pipes. So my instructions to that person was to go out when it's raining heavily and open it up then. And that's where they get the maximum flow through the pipe, because they had so much crud in the pipe that in the pipes they dug up. Pipes are going uphill. And, so highly recommend this to fit to any new wet system. Won't cost much, highly beneficial. Next slide. And the next slide just shows a couple of tanks plumbed by our super diverter. No overflow pipes needed, no vertical riser needed. Tanks will never overflow. You can harvest every downpipe on the house, you can harvest every downpipe in the neighbourhood, provided the downpipes are at the same level. Just put that in for a bit of interest. If you want to harvest more water without fear of the tanks overflowing, check out the super diverter. Thanks, everyone.
Margaret, so Margaret's up next.
Okay, great.
And so, all right. So look, sorry about that, Dennis. Hopefully we can get that problem rectified and move on. So, Margaret, I'll give another little brief introduction to Margaret to help her get ready and make sure she's ready to go. So Margaret's from Moss House Edible Garden, and it's an example of a 13-year-old sustainable permaculture property designed with the primary goal to provide the owners with food, medicine, and fibre plants. Based on that, and she's promised us a very, very interesting presentation. So, Margaret, it's over to you.
Hello, everyone. Am I on? Yes, I am. So I would like to welcome you from Woolloomatagal land, which is in Sydney between Parramatta and Lane Cove River. And I'm going to talk about sustainability in terms of water usage. And I know that with sustainability, everyone talks about having solar panels, water tanks, which I both have, and using various devices to limit your home water use and energy use. So this is what we understand as sustainability, but there is more to it, and not many people are aware of that. So I'm just going to talk to you about other aspects of living sustainably, and let me share my screen. Okay, just moving to, all right. So I'm going to talk about growing food to save water and basically saving water using our gardens. And the reason for that is that growing and sourcing food, it's up to 60% of our eco-print. So it's not really the energy and the water we save in our homes, which is pretty easy to calculate because we pay bills for the energy and for water and for gas, for electricity, which we are using in our households. But we don't see the real cost of food. And that is actually the biggest issue and the biggest contributor to our eco-print. So this energy and the water used to grow food is basically embedded into everything we eat. So when it comes to energy, people are usually familiar with the concept of food miles, which is how far your food comes. So the cost of transport, the usage of oil and other forms of energy to transport it. But it really starts with farming. Because to make synthetic fertilizers, which is the main food producing industry, and to make farming machinery, a lot of energy is used. Oil and oil byproducts are used as well. Powering farming machinery, powering transport, and also powering cold storage facilities. That includes supermarkets, not just big warehouses. And also the cost of producing packaging for food. That's an enormous cost. And this is something we really cannot avoid because we have to eat. You know, we can live in a tent and use drinking water from a stream, but we have to eat. So this is really important that you understand that the real cost of our sustainability, it's related to food. So let me talk about water. So food production, that's the biggest contributor to total household water usage. So it does not matter if you've got rainwater tanks or, you know, water diverters, filtering and reuse gray water, because each person in Australia needs 10,000 liters of water to grow food they eat in one day. That's 3,650,000 liters of water in a year per person. There is no way a rainwater tank could save you this amount of water. Plus about 1/4 of all water used to growing food worldwide. It's to grow 1 billion ton of food that nobody eats. It's the waste, and it could be wasted in households, but there is also a lot of waste which is related to the farmers being contracted by bigger companies, supermarkets, and so on, which require certain size and color of the fruit and veggies supplied, and whatever is too small or, you know, non-standard gets destroyed. So we actually lose 1/4 of water which is used to grow food because it gets wasted. So again, the numbers, 10,000 liters of water are used to grow food each of us eats in one day. It's a little bit more for people who eat meat, it's a little bit less for people who are vegetarian. So that's pretty shocking. Now you can see the cost of common foodstuffs in terms of water. So per 1 kilogram, or, you know, in cotton it's 250 gram, milk is just 1 glass. You see how much water is used. And remember, when we talk about meat and, you know, other animal products like milk and cheese, we also include the water which is used to grow food for the animals. So it's not just the water the animals drink, it's also the water which is needed to grow all the fodder for various, you know, sheep, cows, and so on. So you can see it's huge amount of water, and it all adds up to about 10,000 liters a day. Beef, 1 kilogram of beef. Okay, nobody would probably eat 1 kilogram of beef, but 1 kilogram of beef, that's 15 tons of water. So it's really huge amount. So what to do? Because food production is the biggest contributor to our total water usage, growing food on site in our gardens, it's the best way to save water, not rainwater tanks. And so I will talk about growing food. I will talk how to prepare garden soil to store water and to use water-saving garden tricks. But even for people who are not willing to grow food, or, you know, you don't have time, or your garden hasn't got enough sun, you can still use your garden to filter the water so it actually returns to the ground and replenishes groundwater. So the water from your garden actually does not go into stormwater drains. So water-wise garden design. So this is really smart way of saving and conserving and recycling water. And such type of water uses such type of garden uses less water, and also conserves the water you use on it. And you can also use your garden to recycle water. So let me talk about reduced water usage, conserving water, and recycling water. And you can see that's the surface of a little garden pond I have. And it's covered by a native floating fern, which is actually tiny. This is about 2 centimeters plant. And it protects the water from evaporating from the surface of the pond. So, you know, one of the ways of protecting water. So reducing water usage. If you have a good design, like where do you have your plants? Is it in a sunny area which needs more water or shade? You have to know how the rainwater flows through your garden. My garden is on a slope, and the difference between the street level and the back fence is 11 meters. So it is pretty steep. So the water flows down, but not until I've got like 25 centimeters of rainfall in one day. I really don't get much flow of water from the garden into the storm drain. You have to be aware what is the wind direction, because wind can dry plants, and also frost traps, because cold air tends to flow down the slope and sort of pull in sunken areas. So you need to know your garden to work out how to reduce water usage in your garden. You have to plant appropriately so you don't waste water. So you try to put plants which require more watering together and plants which can deal with some dry weather in a separate spot. Don't mix them, because that won't be good for the plants, because they will get either not enough or too much water. And the proper watering of your garden also reduces water usage. So I use mostly rainwater tanks to water my garden. And I have 10,000 liter water tank, which is connected to the house. So I use it in the laundry and in both toilets. But I also have freestanding rainwater tanks, about 3,000 liters, which I use to water the garden. So only when it gets really dry, I start using my major rainwater tanks, because the smaller ones can run out much faster. So proper watering of your garden depends on the time, how often, and how you water. So it's best to water in the morning or in the afternoon. It's better to water not too frequently, but pretty deep. And watering methods, I know that we all love to walk through the garden with a hose. It's very cathartic, watering the plants, but it does not work very well. Better watering methods is either using a drip system, or using perforated aqua pipes, and using self-watering garden beds or wicking beds. So deep watering, not too often. Now, how to conserve water which already falls on your garden as a rain or snow, regarding where you are. And of course, if you use city water, you also want to conserve it. So you want the water to go a long way. So important thing, to increase water holding capacity of the soil. The best way to store water, it's in the soil. It's not in rainwater tanks. When it comes to water, and I grow a lot of my food in my garden, if you have water in the soil, it will feed your plants, and also it will percolate down and replenish groundwater. You need to limit evaporation in your garden. So your ground, your soil has to be always covered. So you may have various mulches, like woody mulch or sort of straw, hay mulches. You may have living mulches in terms of plant cover. Nasturtiums are great for that, for example. If you have drying winds, and because my garden is on a hill, I face really drying southwesterly and southerly winds. So you have to create some sort of wind breaks so the water you use on your plants does not evaporate too fast. And it could be wind breaks by using fences or by using hedges or various plants. I usually have trees as protection from the winds. And in your water, you can also create structures to hold surplus water, which sort of flows on the surface, and your ground is so soaked, the water is not really getting into it. So you can create trenches and pits and rain gardens, so you store the water in the soil for longer. Now, how to build absorbent soils. I've got clay soil. It's a brick quality clay. There is actually a place of old brickworks 2 kilometers from me. So what I did, I basically broke the soil with fork. I added some gypsum, some sand, and a little bit of vermiculite, and that opened the soil so it absorbs water. If you have sandy soil, you may use additional clay, and compost is always good to add either to clay or to sandy soil, because it will hold water. Organic mulches, animal manures, compost on surface of the soil. Earthworms and plant roots will actually work on pulling this material into deeper layers of the soil. And planting green manures, you can see this is perennial green manure, which is comfrey. I just chop and drop it around my fruit trees. And this is annual green manure, which I use to cover fallow pieces of the ground in the time when I don't grow my food. So mostly, sort of in between seasons. Water holding structures. If you have a steep garden, you may dig horizontal trenches, which are called swales, and in my case, they are filled with wood chips. I've got 5 of swales like this, and the soil I dig up when I make a swale, I put it down the slope and I plant trees on it. And because water gets collected in a swale, I will show you a diagram in a moment, it feeds the soil which is below the swale, and it sort of percolates into the ground really slowly. And even in after really dry days, when I dig through the wood chips, I will see it's really moist. There could be even water at the bottom of the swale. So this is how a swale look like. I also use swales to take the water, the overflow from my rainwater tanks. So they go into swales, and again, that would go into the soil. And I also use the overflow from my pond, which has got a little overflow, so the water does not go over the top. The overflow also goes to a swale. So basically, that's where I planted most of my perennials and the fruit trees on a swale system, because they hold water. You can use bog gardens. So you can create a garden, part of garden or sunken garden, which will hold water, and you will grow plants which can deal with being covered with water completely. So you can grow edibles, water chestnut, watercress, arrowroot, or you can just plant native bog plants, which will sort of dry out if it's a heat wave and it's really dry, and then they will resprout when after rain your bog garden fills up. And rain garden, it's a similar variety, but it could be put in a raised garden bed, and it's for filtering water which comes from your drainage pipes or overflow or gutters. So it will be released slowly into the rest of the garden. So again, you avoid the water just running off the surface of your garden. Self-watering garden beds. This is absolutely great thing. And this is how I grow majority of my vegetables. I've got 11 raised garden beds, and 8 of them are self-watering or wicking beds. And that's where I grow most of my annuals. So, you know, all the typical veg you usually buy from a supermarket. So the water reservoir is under the soil. So you've got pipes, you can have pebbles or special plastic forms like water ups. Then you put non-woven weed mat, something like ag fabric or geotextile, and you put soil on top. I usually put a layer of vermiculite, and the water level sort of touches the vermiculite when I top it up through a pipe, and then the water gets wicked up into the soil. So usually the highest level of soil here would be 30-40 centimeters, because the water cannot get wicked against gravity much higher than that. But it's absolutely great. It saves me a lot of watering, because the water is always deep in the soil. So it encourages plants to grow long root system to reach the water. And if you only water from the top, that encourages the plants to spread the roots pretty shallow. And if it gets really hot or you go away on holidays, nobody waters your garden, your plants die. So deep watering, it's always the best. Self-watering vertical gardens. This is my garden, this is my friend's garden. It's basically pots which are hanging in a poly pipe. They are not standing in water. So each pot has got 2 wicks which are made from ag fabric, geotextile, or something like old polars, not natural fibers, because they would decompose. So the pipe is blocked from both sides, and it's got a little hole in the side, which is like an overflow. And then I basically take out one of the pots, fill up the pipe, put the pot in, and all pots are fed with water through the wicks, which are in the pots. So actually this article about this has been published in the Renew magazine. I think it was about 2 years ago. So you can also use this when you don't have access to a lot of garden, or your garden, it's really shady, but you've got a lot of sun on the walls of your house. So you can grow your food on the walls. Now, recycling water, you can use your garden to recycle your gray water, and a lot of people are aware of that, but it does not have to be very technical. So you can bury the pipes under mulch, and you can direct the water straight into plants, and it's mostly fruit trees which are watered that way. But you can also filter it. So you can use, for example, recycled and filtered gray water to top up your pond, or some other area which needs a lot of water. So for example, this is a setup of one of my friends. So where you see this dot, that's where her house is. And she's got her laundry water going into a reed bed, which is full of little pebbles. And she has planted native reeds, which are plants which use nutrients from the water, but they also add oxygen to the water through the root system. So this is from the time when she started the system, but now it's just overgrown, just full of reeds. And the water runs through overflow into this trench, which is a swale, and it feeds her fruit trees. So she saves gray water, filters it, not using anything technical, basically just plants. And this clean water is then used to water her fruit trees. So you can also direct gray water, not even clear. Obviously, you won't use normal commercial laundry powders. You probably are aware of that. You need low phosphorus, sort of ecological. You can get washing powders and liquids which are designed for a closed system and so on. So such gray water can be diverted to composting pits. And composting pit is basically large hole in the ground. In my case, it's about 1 meter wide and about 1 meter deep. And I surrounded it with bananas and pawpaws. And inside the pit, I just throw all weeds from the garden which cannot go into compost. So, things with rhizomes, with seeds. And you could use gray water to put in the system and basically grow a lot of fruit, not really watering it in other ways. So just using gray water. Other ideas to grow food and to keep your water use pretty small, it's aquaponics system, which is a combination of hydroponic system and aquaculture. So this is, again, my friend's place. She's got a large fish tank under her balcony where she grows silver perch. And the water, which is full of nutrients because, of the fish manure, it's pumped up. And here on the terrace, on the balcony, she's got a garden bed, which is filled with pebbles and special bacteria, which converts the nitrates or ammonia from the manure into compounds which can be used by plants. And the water goes through it and it's filtered by the plants, it's oxygenated and goes back to the fish tank. So I'm just going to show you a little setup. That's how it looks like. So you get a special bacteria like Nitrosomonas. So the nitrite from ammonia from the manure, it's converted into nitrates, which the plants can take up. And then you get bell siphons. So when the water level reaches sort of just below the level of the pebbles, the siphon empties the water into the fish tank. So, I could talk about the water-wise garden for about 4 hours, but I guess my time is nearly up, just checking. So another thing, which again, that would be like 1 hour talk, go to sustainabletable.org.au website. Because even if you don't grow your own food, this website gives you some hints how to limit the cost, water and energy cost of your food. So how to basically lower your ecological footprint, which is related to what you eat. So where to shop, eating less meat. If you only eat meat twice a week, you reduce your food-related footprint by 40%. It's as simple as that. Buy seasonal stuff because it's not imported. Reduce food waste, compost food scraps. And if you don't have your own garden to do composting, use a service, swapping service, which is called Share Waste. And basically it links people who have waste they cannot compost themselves and people who would happily take this waste. It could be community gardens, larger gardens like mine, farmers. So, you could get rid of your waste as well. Ethically raised and sustainable meat and seafood. It's a good source again of reduction of your footprint. Grow your own food, always. Eat whole foods, so not processed, not flours, but grains. Avoid packaging. A lot of energy goes towards packaging and especially plastic. And obviously, in general, refuse, reduce, reuse, you know, the mantra of not creating more waste, and ask questions about where your food comes from. So that's from me. And you can have this information if you ever want to contact me. I believe it will be also published at the end of this presentation. So that's all from me.
That's awesome, Margaret. That's well done. Thank you very much for that. I found it quite interesting. I'm sure other people did as well. Where 10,000 litres of
per person
per day. I'd heard a recent thing which said 2,000 litres, and I thought that was pretty over the top. But 10,000 litres, that's
10,000 litres. It's
amazing.
It's calculation by Stockholm Water Institute, worldwide institute which does research on water.
It's absolutely amazing. Look, thanks very much for that talk, and I'm sure you'll get quite a few questions coming through on that one, because I think it's opened people's minds.
It's very different.
Oh yeah, and it actually now segues quite nicely into the talk we have from Roman. So again, we have Roman Spur from the Spurtopia homestead, who's also aiming to be self-sufficient in energy, water, food, and waste-free. So he's going to have a very, very similar related views on the use of water in that whole sustainability sector. So Roman, you have about 20 minutes starting from about now. So I'll introduce you to Roman, and you can start your presentation right now. Thanks.
Hello, Michael. Hello, everyone. I hope that you are fine today, and I am aiming to inspire you to grow your own organic food and obviously save a lot of water. But I also would like to share with you some ideas, inventions, knowledge, and experience, and empower you to make a difference. And at the end of the day, I would like you to think out of the box. So the first thing to know about household, if we're looking at a water consumption, where all the water goes to, and nearly half of average household water consumption goes into the garden. And then you can see the bathroom and laundry, just the proportions of the other half. So on average, average household will use about 900 liters per day, while our household use around 230 liters, which is about 25% of average Australian water consumption. Here is a bit of story. When we arrived to Australia 12 years ago, we actually established ourselves in Brisbane City, where we rented a unit in a new farm, and there was a small backyard. So for most people, they would say, oh, renting and don't have a land to grow, you can't do too much. But you will see how much you can do, and everyone can do. There is no excuse. So this is the layout of the place, and you can see that actually the vegetable garden is very small, and we had a large concrete yard and shed. So not a lot of space, but we managed to grow more than half of our family food consumption in this small backyard, and we actually produce even excess, which we share with the others. So here we go about rainwater harvesting, and I actually would like to point out, everyone has got a rainwater tanks, either large or small, like these IBC tanks. But that's what we did in our rental property. That's the downpipe, stormwater downpipe, which we kind of diverted into these IBCs. There are 3 of them. And obviously, when you are harvesting rainwater, the first flush is always dirty water, and you don't really want to use it as a drinking water. So how does that work here? So water goes into the first tank from the top through the T section, and it's kind of sealed off. So when this rainwater tank fills up, it actually water starts to flow into the second one, and then when that one fills up, it will overflow into the third one. So the third one, you can see it's covered in a black plastic, and that stops algae growing there. And that was our drinking water. The first 2 IBC tanks we actually used for the garden. So when you think about it, the first flush, there are the systems which actually first flush would be, say, something like maybe 10 liters of water. But 10 liters will definitely not be enough to harvest clean water when the air is polluted and when the roof is polluted. So when you think about it, 2 cubic meters of water, that's, I think, very good to get the clean water for drinking, even in the city. Yeah. And actually, how we got this water from these tanks into the garden, there is a swimming pool hose connected to them, and by gravity, actually it flows into the garden. And I used actually vacuum cleaner pipe to get to have gravity fed irrigation system, so I could walk around the garden and water it. When we're talking about gray water from washing machine or showers, what we really want to do is to use it straight away. Once you store it for say more than 24 hours, it will go stagnant and it will kind of go off, which we don't really want to. So in this case, what we did, we didn't have the flexi hose long enough. So I actually connected that to the bucket, and of that bucket, I actually made a hole with a green garden hose, which actually went all the way down to the garden. So in that way, we actually, in rental property, we actually could use gray water to water our garden. You can also use swimming pool sand filter to water the gray water from gray water tank, and then use it later on. I will talk about it shortly. So here are some ideas for you when we're talking about self-watering wicking. You can use a milk container as a wicking pot, and you cut it half, you make a hole in a lid and put there a piece of fabric, and the bottom part is water storage, the top part soil and plant growing. So that's very simple. It will hold about half a liter of water. You always will see how much water is left. So it doesn't need to be top up every day, maybe once in a week. But being an engineer, sustainable design engineer, for me, it's not enough. So using all available resources. So this is actually plastic 20-liter drum from cooking oil from our local restaurant. And what I did, I actually chopped the top off and made a holes, and a couple of holes for legs, and put it into the drum. This black pipe is there to get water in, and you have got 20-liter self-watering planter pot where you can grow whatever you like. So the next slide is, look how we had a brick wall which looked really awful, but with this wicking pots, it actually all of a sudden turned quite well. Looking at Margaret's presentation, we also used vertical garden as a poly pipe, stormwater pipe, and grew strawberries there. But as a water storage there, I actually use macadamia shelves. As a half of that pipe filled up at the bottom, that was a water storage. And water actually was automatically supplied from this plastic bottle. So it actually could go without watering for quite a long time. But again, it's not weeks. And for me, that's not enough. So I went further and was using this, or still using this styrofoam box as a self-watering plant box. And everyone can make it because it's so simple, very light. You can transport it. You can use whatever material. It doesn't need to be a styrofoam box. I just use that because I could get hold of it. In essence, this self-watering plant box, that's a lid which is cut to fit, and there are PVC pipes as a legs, but also as a wicks. You don't need to have a PVC pipe. What you can do is to have a plant pot, and the lid would be sitting on these pots. So the lid goes in like upside down. So that creates water storage. And then you fill it up with soil to all the way to the top. But the most important part is that the soil needs to go down to these pipes, because that will create a wick. And the state-of-the-art technology, you can see here a float, which is wooden skewer and styrofoam offcut. That will tell you how much water is left in the styrofoam box. And also the styrofoam box will have an overflow hole, as you can see that here. And that is at the same height or slightly below the suspended, the raised floor where the water storage is. So the idea is that water will never reach the actual soil in the box. It will be always lower. I took it even further, because that box will store about 10 liters of water, but made a double box or triple box. And the same principle, the bottom storage, the bottom box is the water storage. In this instance, the second box has got a pipes going all the way down. You have to stack it up, not like that, but you stack it on the top of each other. And the third box, I cut the bottom of it off. So you have got about half a meter depth of soil, so you can grow there even a root vegetable or a small fruit trees. So what we did with that, we actually created a fruit and vegetable pyramid on a concrete. And even though it's in a full sun in summer, the plants are still happy because they've got constant supply of water. But you can use any materials. As I said, here is a blue drum, 200-liter drum, which I cut half. And the same principle, half of it is a water storage, the bottom part. The top part is soil, and growing even dwarf bananas in it. Yeah? Here is how it's actually done. A mesh, a few stormwater pipes as a legs, and geofabric to hold soil there. The other one we actually cut alongside and had it as a water storage. The same principle, had larger root growing area, and you can see even a self-seeded pawpaw growing out of it with 4 pineapples, and we're already getting pineapples over it. Here is another idea about watering fruit trees, deep watering fruit trees into the root zone. So rather than standing with a hose and watering that from the top, you've got a copper pipe, which I actually bend it at the bottom and created like a spray, and I poke it in the ground say 20 centimeters deep, so that will actually deliver water directly to the root zone of the plants or of the trees. So in that way, it's much more effective. That's our place when we started, 2009, and that is the place a few years down the line. So you can see that you can create your paradise even in a small space. But then we actually we actually bought our new place in Fernwell, which is about 1 hour drive west from Brisbane, where we have got 1 acre, and we actually established the whole place as a sustainable place, and there is so much to share with you, so I will go through it quickly. So that's the layout of the place. It's triangle shape of the land, and it's on a slope, so we're actually using slope to our advantage. And very, very important, when you're setting up your property, it's very, very important to have a vision. And that's what we did here. There are a few slight changes. For example, dam is not there because council would not allow us to build a dam unless we fence it off like a swimming pool, but we can go around it in different ways. So the first thing, we actually got rainwater tanks in, which is these two are 22,500 liters each. And I had to connect the roof to them, so fair bit of work, good exercise, keeps me fit. And that's how we started. And from our experience, we found that these 2 tanks would be enough to run the whole household, family of 5, throughout the whole year, just on a rainwater. And these are just the beginnings, where we had these as a self-watering planter boxes, where we actually could grow something green, and that's how we started. And obviously a lot of compost, and compost, as Margaret already mentioned, would store a huge amount of water in a soil. So the more organic matter, the more water you store in a soil. And that's how we actually started our kitchen garden. And you can see the slope. This is our veggie garden, and that veggie garden is actually built on septic overflow, gravel sucking area, whatever you want to call it. And the weeds were growing like mad, and I had to whippersnip that every week. So I said, like, no, I'm not going to do that. So built a raised garden beds. And the point here is that plants which has got larger root systems like tomatoes or zucchinis, they will tap into the moisture of that, so you don't need to water them at all. We also built swales on the property to retain runoff water, and it was a lot of hard work and improving the soil as well, because nothing will grow in the soil apart from gum trees. And you will see, how the swales work. Actually, that's how they actually hold water, and we have got 3 of them. So when one is full, it will overflow into the second one and into the third one. In this instance, we had over 250 mil of rain, and it wasn't established yet. So you can see how it actually was breaking through. But now the swales look completely different. So here are some ideas for you how you can build your self-watering raised garden beds. In this instance, a plastic liner, builder's liner, and hardwood wood chips. They will actually stay as they are for several years before they break down. Then I put a shade cloth on top. You can use a geofabric, even better, and the soil. The Aggie pipe is there to distribute water into the wood chips. You can even improve on that to put alongside the stormwater pipes, one next to each other, and between them the hardwood wood chips go into. So you've got far more water storage. The difference between hardwood wood chips and pebbles is, or in general, that the pebbles would take up to 70% of water storage space. So only 30% is actually water storage, while wood chips would actually soak up, and you have got more water stored in that way. Here is another idea. I always use materials which I have available. So I've got these bricks with these holes and grills, and each brick with each hole is actually a wick. So fill that up with dirt and then put the soil in, and that's the final result. So the advantage of this system is that it will store maximum amount of water in that bottom reservoir. So most of the space is just water storage. Instead of bricks, on the other garden bed, I actually used planter pots. This, say, 15 centimeter diameter, about 15 centimeters tall, and when they are filled up with dirt, they are structural, so they will not collapse and they will hold the weight of the soil. Here is our energizing mandala pyramid, and that's another way using another material to make wicking garden beds. And as you can see on top right, use the bricks to support the stripes of corrugated iron. I didn't have a steel mesh, so I use strips of corrugated iron and made the gaps between. And then on the top, I actually put the shade cloth, and the shade cloth goes down into the gap and up, creates like a pocket for soil to go in, and that actually creates a linear wick. So I created the whole pyramid into the few sections. So just in case one will start to leak, the other ones are still working. Here is another idea for you, and that's herb spiral. Herb spiral is very old idea, but what is innovative about this herb spiral? It's self-watering. In this schematic, you can see it has got actually 3 layers or 3 water reservoirs in 3 layers, and this is how we actually build it from 0 to all the way to the top. Use a recycled carpet from the house as a stones as a water storage, and dirt around. So that was our first layer, and then we started another layer the same way, and the 3rd layer. And finally, we actually achieved the herb spiral. We just got 3 water reservoirs, and I can tell you it really, really works. Here is a bathtub. You can convert a bathtub into a beautiful garden bed, and I actually silicon in the tube to get to keep water in. And it's the same height as the grill. So the planter pots are there as a wicks, and they also hold the wire mesh, and geofabric actually holds soil. So these recycled bathtub, they would hold up to 100 liters of water. And they are great for growing cucumbers, for example, because cucumbers will need water all the time, and that's where they get it from. So that's the kitchen garden, continuing the story. That's how it looked before, and that's when we actually kind of established that. Yeah, that's the bigger picture. That's the veggie garden. When it was kind of established, and that's 1 year later on. You can see it's actually changing and not using as much water. That's another view at the property, and you can see how everything is actually growing. Coming from Europe, using this is a different way of environment and have to start the view at a gardening in different way. So for us, wicking is like a no-brainer. That's the way to go because it will save a lot of water and energy.
So Roman, we're pretty much running out of time now.
Yeah, I will just finish it in a minute.
Okay,
yeah,
no worries,
thank
mate.
you. So that's the comparison to when we bought it and 2 years down the line. Another photo. At the moment, that's another way of watering. Here are the water-wise tips. Deep watering definitely create a shade in summer. Add as much compost as you can and mulch. Water harvesting systems, use a rainwater rather than using town water and so on. So yeah, plenty of things to share and plenty of things to inspire people. So I hope that I got you inspired and thinking about how you can actually grow your own food and save a lot of water.
Excellent. Thanks very much, Roman. That was amazing and such a great follow-on from the presentation that Margaret gave earlier about using sustainability on your own property to save water. And if we can do some of the things that you've done on that property, then we can save thousands and thousands of litres of water per person per day. Look, let's move on now, and we'll invite the presenters so far. And Dennis, please keep trying, because if we can get you in on the panel discussion, that would be great as well. But we'll also get in Eric from the Earth Care Centre to come in, and we'll do a bit of a Q&A. So we've had some Q&A questions come through during the presentations, and I'm just going through some of those now. And there was a question very early on in Margaret's presentation, which was from Julian, about how safe is roof sourced water. Now, both Margaret and Roman mentioned getting hold of that water and using on the garden or diverting it somewhere else because it might have some contaminants in it. Perhaps, Margaret, if you could just spend a minute or two explaining about what the potential issues are with the water, and Roman following on from that, and then I might get Eric to come in and talk about that as well. And as well as that, someone wanted to also recommend a brand of laundry and dishwashing detergent for the grey water systems. So Margaret, if I can pass it over to you first.
Thanks, Michael. Regarding how safe the water is, if you are familiar with Michael Mobb's Sustainable House, he is in Chippendale near the center of Sydney, and he actually did testing of the water quality in terms of chemicals compared to normal city water. And despite being in an older part of the town where, a lot of traffic and previously lead gasoline vehicles were, still the water from his roof was better than the city water. So that's the first thing. Second thing, you have to make sure that you don't have lead on your roof. And I do have some lead, so I only take water from about half of my roof, because I've got lead flashings around the chimney, which I plan to remove, but that's what I've got. So things to be aware of, it's you may check the quality of the dust in your area. And you may try to collect some dust, just set up some sort of container open to the elements and get dust that way. Or you may check Michael's Mob book and also contact him and check, how he tested. What is also important, which also Roman has mentioned, is having the first flush diverter. So the first water which falls when the rain starts, it's the dirtiest water. It will have some, animal droppings, bird droppings, dust, whatever residues on your roof. And I also divert my water before it hits the water tanks. And another thing, if you use it for drinking water, on the way from the rainwater tanks into your home, it's a good idea to have filters. So that's all my advice about
Thanks, Margaret.
from the roof.
Roman, do you have anything further to add to that?
I would add the first flush diverters, as you would usually get installed. They are not enough because it's, say, something like 90 mil pipe, 2 meters long. So that will hold maybe, if a lot, something like 5 liters of water. So 5 liters of water, and then water goes into your rainwater tank. And 5 liter is definitely not enough for cleaning the roof and have a clean water from air which is polluted. So I definitely think that you need to have a much larger first flush volumes before you actually get it into your rainwater tank. If you do that in this way, then I think that you don't really even need to have a filter on your rainwater tank because it's literally distillated water. And
well, it depends on the bacterial growth in your tanks.
True, but if there is no lights or no algae growing, and what we actually do with our rainwater tank water for drinking, we actually put it in a vessel and leave it in sun for about 3 hours. And actually sunshine provides UV, which would kill potential bacteria which could be there. Not only that, it would energize, and other elements would be added, and we actually have it in our energizing pyramid. So that's another level of thinking. But then we also put it into like a ceramic vessel, which is completely enclosed, and there we have crystals or stones which actually remineralize this drinking water as well.
So it basically depends on how big is the part of the roof you are collecting water from, and then you have to calculate back to know how big the diverter volume should be.
Yeah, and so Eric, we've got water diverting systems on the Earth Care Centre, and so how do you guys manage that there?
Yeah, well, we actually have town water because we're in the Hawkesbury area on the campus of Western Sydney University. So we're actually on the peri-urban. So we're sort of like in the country a fair bit. So already there's a lot less, I think, like diesel fumes and things coming into the water. So the particles and the pollution is less to begin with. But we're also on town water. And we also had a dam down the back that we were using for irrigation as well, with a windmill pump. But the tank itself, we would have just the first flush device too. But Roman's point is really interesting too. The calculating the volume, I think, is really important too, and that's like the surface area of your roof, coupled with the amount of pollution you expect to get there, and then divert that water somewhere else. So yeah.
And there were a few other questions coming through on some of the other chat lines about UV sterilisation. I think we've covered that with Roman. He does his in the sunlight, but there are commercial systems around which can help sterilise and treat drinking water and make it potable. And so you should always follow the directions of your local councils, and you should always take into account the safety of drinking water, and make sure that you are confident that it's safe for not just you to drink, but for other people to drink as well. So there was also the associated thing with the grey water, with recommending a brand of laundry and dishwashing detergent. Do you have a view on that, Eric? Have you got any list of those? I know ATA put out a list Renew put out a list a few years ago. Yeah,
it's interesting because I've actually got a system at home too, where I've got a composting toilet and a reed bed, and indeed the grey water, I mean, to be phosphate free is not necessarily all good, because I've got plants in there too, and they can do with a bit of phosphorus too. So low amounts of phosphorus is okay, but if you really want to avoid it, then I think it's pretty clear usually what's low phosphorus, and there's a lot of products in the market that I think the competition's there, that it's easy to pick a product that's going to be relatively, unpolluted, I think, for your grey water. But yeah, but if you've got the fish in there too, you need to be extra careful too, don't you? I'm interested in Margaret's comment about the bacteria too, how she gets that bacteria in there, because they are effectively, converting that material into a plant available source too.
You can get the bacteria from other people who have aquaponic system, or you can buy them in a powder form.
And so, Margaret, you actually specifically mentioned before about the laundry detergents that we should look for. Do you have we're not endorsing brands, by the way. This is not an endorsement of particular brands, but are there brands that you have used in the past which have worked for you, for example?
All right, I don't have a grey water system because I would need to pump it uphill. My house is at the lowest point of the garden. The garden is up from the house. So I don't actually use the grey water. I plan to do a reed bed below the house in the front garden. But at this stage, I basically just use low phosphorus. And, I use a lot of natural stuff. Like I make my own washing powders from washing soda and other components. So probably people who have grey water systems will be better than that. I would say using products which are labeled as either low phosphorus, low boron, and also for septic tank use would be the best indication. Eric, Roman, do you agree? Because I don't have much experience with that.
Yeah, I don't, are they still using boron in detergents now? Because I think it's pretty recognised that it's there's other ways to get the effect of boron.
I don't know. I just seen someone's comment in the chat.
Yeah, indeed, and it's interesting.
We actually make our own detergent. It's made from washing soda, soap, and a bit of borax. The exact recipe is on our website, but borax is a boron, and it's toxic when it's in huge quantities. But we have to also bear in mind that the soil is depleted here in Australia from all the minerals. So it actually needs a bit of boron in a garden. And if you don't discharge the grey water into the same spot, you're actually bringing the boron into the soil. And to give you an idea, in terms of boron, a tree would need something like a tablespoon of borax a year. Yeah, so that gives you an idea, how much you can use. So because we actually make our own detergent, we are happy to use on our garden because we know what goes in.
Okay,
yeah.
That's and the other thing is, I suppose it comes back down to read the label on the thing, and the soil health can be a fairly complex subject, and so there are some other resources. Now I know that Renew a few years ago did a few studies or had studies done to recommend ranges and types of laundry powders. I'm not sure if that's up to date, but I think we do have a reference to a website somewhere which we can probably dig out and publish at some point in time for that. We had some other questions concerning foods and everything. One was, and again, this will probably come back to, I'll open it up to everybody, but Margaret and Roman have already spoken a bit about it, specifically about vertical gardens. So how do vertical gardens cope with being on a west-facing wall, and what consideration needs to be made for the heat in the afternoon sun? So perhaps Margaret, jump in there first, and then we'll follow with Roman and then Eric.
I think someone has posted a link to the Renew article on my vertical garden. That's the one. That's the one when I use pots sitting in separate slots in a polypipe, and that gives enough volume of the soil and also a lot of water sitting under that I have my plants on dark brick wall facing northeast. That gets very hot. So not even, western sun, but even northeast, it's very hot. So I have no problems.
And so the water doesn't get too warm? What happens when the water gets warm inside the pipes?
No, you can actually paint the pipes, because I use the orange pipes, which I use to store electrical cables underground. So my pipes are 15 centimeters across. They are bigger than guttering pipes, so they hold more water. And if you paint them in a light color which reflects the sun, that would also help. You could also paint the wall behind the plants. You know, you paint the wall of where your vertical garden is, or you can put some sort of board painted white, so it's there for summer, and in winter you remove it so the wall is warmer in winter. But I don't have any problems. I mostly grow strawberries. I grow some medicinal herbs like coltsfoot. I grow capsicums. So I grow a variety of plants, but you have to remember that the root system has to sort of fit the pot. You can have the pot a little bit smaller than the normal root system because, you know, the soil is rich, you add compost. You can also add the fertilizer like worm castings and worm weed to the water, which sits in a polypipe. So you can actually fertilize with the water the plants take up.
Okay. Yeah, and Roman, you specifically mentioned the vertical plants in your garden.
Yeah, what I actually like Margaret's idea. What I would improve on, especially on a western-facing facade, I would definitely, if at least painted the pots, because if the pots are black, you're literally cooking the root system.
They are gray.
So
they are silver gray and pink and light blue.
Yeah, so one painted, the other one, what you can use is actually pot in a pot. So in this case, you would need to kind of cut off the bottom of a larger pot, which would go in over the existing pot. So the air cavity between the pots will create insulation. Or you can use a Hessian bag or whatever to cover the whole thing. And in that way, you're actually keeping the root system cooler and the plants will grow better.
Yeah, I've noticed that when I've got a large collection of pots and 10, 15, 20 pots of various sizes, the ones in the middle do much better than the ones on the outside because they're probably protected from that temperature. Eric, did you have another comment to add to that?
No, not really, because I mean, like I said, we're in a peri-urban area, and so really we have a hectare of land, and so there's plenty of space to grow lots of things, and and I guess the old permaculture principles apply, don't they? Zone 1, you try to pack it in, but but I think that stuff on the outside wall has the effect also of insulating the inside of the building as well too.
That's another advantage, yeah.
Yeah, but very tricky, as Roman and Margaret said too. I mean, the volume of soil you've got there to put those roots in, you can cook plants very easily.
Yeah. Here's a question I think is specifically for Margaret. Nicholas has asked, have you tried growing mushrooms as a protein source, and what's the water demands for mushrooms?
I haven't tried growing mushrooms because I actually go and pick wild mushrooms.
Okay.
So I'm a mushroom picker, so no, never tried growing them. And the setup for the mushrooms, probably the easiest ones to grow are oyster mushrooms in buckets, because you don't need to be very careful with them, when it comes to sterilization of the environment and a lot of water. I actually grew some oyster mushrooms in a bucket in my bathroom. Just to check how it grows, but I'm not a very experienced grower of mushrooms because I mostly pick them wild, freeze some, dry some, pickle, ferment, so I always have them.
We had a friend who accidentally grew mushrooms in their bathroom once. Yeah, that was another story.
on this topic, if I can add, you could actually grow oyster mushrooms in coffee grounds.
Yeah.
Okay.
So you can actually utilize coffee grounds in that. But even better, you can go and get mushroom compost from mushroom farm, and they're growing these mushrooms in the bags. And when they are exhausted, they're actually getting rid of the bags and putting there new ones. So you can buy usually these bags for $2. And if you actually place them under the house or somewhere in a cooler area and cover it, you will still get about a kilo of mushrooms out of it. And as a bonus, you will get a mushroom compost eventually. Yeah. So that's something to consider as well.
Okay. So we've got a few questions coming in on various themes, and One of them was a really specific one for Roman. Very quickly, you used they're interested in the deep copper copper pipe you used for deep watering trees. How did you make that? Or is there some that people can? Is there some people can actually read about it, perhaps on your website?
It should be on the website. If not, just drop me an email and I will send it to you. But I will try to explain. If you just have a normal copper pipe and you poke it in the ground, you actually plug it with the soil, and it will not really grow unless there is a huge pressure. So what I did, I actually cut, say, half of this copper pipe, about 2 centimeters into the length of the copper pipe. Yeah, so cut that half off, and with the other half, I kind of created like a lip. Yeah, so it actually water created like a hole to the sides, if you know what I mean.
Okay, yeah.
I bend it over, so in that way you can poke it in the ground and it will not plug.
If
and you connect it to a normal hose through a valve or whatever you want to, whatever materials you have available, and that's how you actually water the fruit trees if you don't have enough water and you want to water the root system.
Yeah.
We should also bear in mind, that we should water to the drip zone. So that's usually where the canopy tree ends, not around the trunk. That's the feeding roots of the trees are at the end of the canopy of the
drip line. Yeah. I was going to make a comment something like that. How do you both Margaret and Roman, you've used wicking beds, and so the question is from Emily and a few others: how do you avoid getting mosquito wrigglers into the wicking beds? Can't they just get down the pipe when you top up the water?
I just cap the pipe. I just put a cap, or you can put a small, even a small potted plant. But I basically just cap the pipe through which I'm going to add water. That's all. Never get mosquitoes into my watering beds. And also, if you've got the overflow pipe from a wicking bed, it's a good idea to put something like a piece of fly screen over it, so you don't get mosquitoes getting in through the other end of the system.
Yeah. Roman, you do the same sort of thing, or Eric, have you
got? If you could see, there is a float in this pipe to get water in, and that's styrofoam offcut, and that's around it as a pipe. So I'm actually physically blocking the mosses to getting into the water storage at the bottom. This is the float. And in terms of the overflow hole, you either make it small enough, so you in a styrofoam box, you just poke a screwdriver in through the styrofoam, and in that way the hole is small enough so the mosses will not get in, or you just put their fly screen or something over it.
Yeah. And I do the similar thing with a tank I have, which is it's just a 200-litre drum that I use as a tank to water the chooks. Well, not water the chooks, but provide water for the chooks. And it's just got an opening at the top, and I just got a bit of wire and wrapped it in a circle, and then wrapped a bit of shade cloth around it. Just sits over the opening, and that stops them as well. And it's just a small stone on that to hold it in place. And Eric, have you have that sort of issue with your system at home?
Well, I mean, Earthcare, we don't have wicking beds, and I don't have a wicking bed here either. But yeah, I mean, you've got to be conscious in terms of, the species of mosquitoes that really like, and the volumes of water that they like to sit in. So once the volumes get large enough, then other ecologies start to kick in and balance that, I think. And I've got a reed bed, and I just make sure that there's no water at the surface, so it's all below the gravel, and the plants come up on top of that.
Yep. All right. Yep. There were a couple more questions, which I think we've answered, Margaret, about the lead on your roof. And you're saying that you avoid collecting water from that section of your roof.
Yes.
And so, how do you know that you're not getting that water sort of coming from other parts of the roof? Did you actually check out the water flow on the roof, or you just block those others off?
My roof has got like 4 parts. It's not flat roof. It's an old house. It's actually retrofitted 1936 house.
Okay.
So I just take water from about 40% of the roof, which is sort of like 2 parts of the roof, and the other two, I've got solar panels on one of them. And then I've got a chimney surrounded by LED. So it's easier for me because I don't have one bit of a roof or, just two, like in some modern houses.
Right. Okay. And the thing is now these days they don't use LED. Well, they're not supposed to, but they don't use LED flashing anymore anyway. With modern
but
builds,
old houses they do.
With old houses they do. And in fact, I'm lucky enough because I've got a colour bond roof, so I'll get even cleaner water than normal. So because I don't have tiles to worry about. Emily asked, how do you with the bath? I think it was Roman that had the bath. Was it Roman that had the bath?
Yeah.
I can't. Yeah. How do you do the overflow on the bath, or how do you stop the whole bath from filling up in heavy rain?
Okay, if you could remember, there was a pipe in a hole of the bathtub which I silicon in, and that pipe is the same height as the pot, which is like a leg holding the mesh and the geofabric.
Yeah, so you drilled that hole
when water
inside.
actually reach that height, it will overflow out through the silicon in pipe out of the bathtub.
Right, and that was one you drilled into the side of the. Yeah. Okay. And the other one was you've made a lot of use, Romy, and well, everybody here has probably made use of recycled materials and everything. How do you go about evaluating the risk of toxic materials, plastics, metals in bathtubs and everything, which might leach into the food? How do you manage that? I might let you, Romy, really quickly, and then Margaret, and then Eric.
Yeah, what I would say is nothing is ideal. So every plastic would leach something. If it's in a plant pot, fine. The styrofoam box, I'm not saying it's ideal, but we have to bear in mind that the broccoli actually comes in direct contact in the styrofoam boxes. And no one think about it. Yeah? And my point is that if you grow even in the styrofoam boxes, the veggies from that would be 1,000 times better than veggies you buy in a shop shelf. Yeah? But you can actually use cast iron bathtub or whatever material you would be comfortable with, and use that. I just using what I have got available. Obviously, I don't want to poison my family with the food growing in it. So use a common sense.
Yeah. Okay. And Margaret?
Sorry, I was just answering a question.
No, that's okay.
I don't really use plastic much in my garden. I do use aquafabric, which is, I think, type of polyester to line the wicking beds. And I also use recycled items, which would be mostly IBC containers, the same as Roman used. I use them as freestanding containers for water running off my woodshed. So it's not a system connected to the house. I mostly use it for watering the garden. But this is a really hardy plastic, and it's also allow for food storage. So I don't worry about that much because it just stores water. It would react more if you put something acidic in this plastic, like soil or say water from your compost, something that's contaminated with organic materials, but just plain water would be fine. The other thing I recycle is old concrete laundry tubs.
Oh, yeah.
So I use them because they are good insulation against the heat. So unlike the metal modern containers, so I use them. And in general, I use a lot of things I found in my favorite curbside markets, which people otherwise call council cleanup days. I grow my own bamboo for stakes and for small constructions around the garden, which last for a season or two. But otherwise, I use styrofoam boxes, but mostly for growing seedlings. Just again, insulation properties. And so I have styrofoam boxes I've been using for several years. and then they go, unfortunately, they go to rubbish, but at least I extended the use of the boxes.
Yeah, we use a lot of styrofoam boxes for seedlings and plantings, and I have a friend who shares a greenhouse with me, and we use those for, or he uses those for growing succulents. So how do you, do you have a problem with the alkalinity out of the concrete from the concrete plant laundry tubs, or are they so old now that they've probably leached anything out?
They must be very old. One looks like it's as old as my house. You know, you can judge by shape. One is more modern. So I would say probably 60, 70 years old. So whatever was there probably leached out for ages.
Yeah.
And
now there was,
I grow mostly medicinal plants in them.
Yeah. So Eric, do you use a lot of recycled material, and how do you deal with potential toxic issues? Are you pretty comfortable with what you're using?
Yeah, I mean, both here and indeed at Earthcare, we used a lot of recycled materials for obvious reasons, you know, because we want to reuse stuff. And but in terms of toxicity, I mean, you've got to, you know, be sensible and where you source things, make sure that, you know, there's things like, you know, I guess heavy metals and chlorinated, you know, things like DDT and all those sorts of things. If you're wary of, you can avoid in the first place. But I think our biology is really quite good, you know, because you tend to get biofilms and algae growing on things very quickly, and I would say that they buffer a lot of those things too. And then there's the pH as well, because we know that things like heavy metals become more available at a lower pH. So
which is more acidic.
More. That's right. The more acid it is, the more available these things. And indeed, we now know that you know, in terms of bioremediation, now we know that fungi are incredibly good at locking up heavy metals and biochar too now as well. They're starting to use, because that's also very good at locking up you know, toxic materials for very long periods of time. So, but yeah, we live in a toxic world, you know, and that's just the way we are. And I think, you look at our bodies, you know, our bodies carry a lot of toxicity with it. And so it gets back to a holistic lifestyle and really looking after yourself and, you know, reducing your stress, but eating good food and, you know, more of your own food too, I think. So it's the whole thing, and a mindset too. I think, you know, our minds can really deal with toxic substances better if you are in a positive frame of mind too.
Just one more thing, following on Eric, you know, the very common organism in the garden, slaters or the roly-poly bugs, they are very efficient in absorbing heavy metals. In the bodies, they create organic compounds which do not dissolve in water. So they are actually used to clear contaminated soil. And I also try to add as many of them as I find into my compost. So they also clear my compost of heavy metals, if there are any there, because, you know, I get straw from growers, which I use with my rabbits and then in litter trays, and then it goes into compost. So remember that there is a lot of organisms living in the soil, like fungi, like the roly-polies, which will clean the soil.
Yeah, and the other thing to remember, just in general, I suppose, in terms of potential contaminants in soil, and particularly, say, from grey water, which aren't necessarily as toxic, that if you're putting them onto plants where you're, even if edible plants where you're eating the leaves and the fruit from those, like fruit trees and things, then that's not going to cause anywhere near the problems as eating plants that grow on or under the soil, so root vegetables or something like that, where you could get those sorts of things concentrating. So it's also about intelligent use of the plants and where you put your grey water and other things like that. On a related topic with that, we had Nicholas was asking earlier, when if you're capturing water in ag pipes, for example, in the ground under veggies and storing it for later use, is algae growth a problem, or is it really worth it, or are you just simply better off using swales as a better method anyway? Margaret, perhaps first.
Algae would grow when they've got sunlight. If you've got ag pipes buried under soil, then you wouldn't have them. But usually the problem with any pipes in the soil is blockage by various animals, including ants, which like to build nests. Yes. So I prefer swales because they are so much easier. So the only maintenance, I just top them up with wood chips, probably once a year, once every 1.5 years, depending how wet the year was or how quickly they decompose. but I would say anything that's buried underground would not have algae, but may have lizards. Anyone who has dealt with the water, normal houses with dead lizards stuck inside, the smell.
Oh yeah. We've got a couple of comments. We've got a couple of questions and comments here that are quite related, and there were some in the comments as well. And that was regarding composting toilets, worm farms, using worm farms as composting toilets, and how good are composting toilets and how good are worm farms. So there's a theme there that people are interested in using composting toilets and or using worm-based ones, because I know there's a number of different composting toilets around. Does anybody have any experience or knowledge of those? Perhaps I might start with Eric, just to see what you've got there, Eric, and then Margaret and Roman can jump in after that.
Yeah. Thanks, Michael. A fair bit actually. At Earthcare, we have a Clivus multrum, which is like uses a sand filter as a secondary thing, but that's a wet composting system. So all the water from the whole building goes in there, and then that water is separated, filtered out, and then that's pumped through a sand filter, and then that's pumped through another filter, and that's put out below, on the ground where it's dissipated. And that's a lot of water that comes through that system. And indeed, that uses worms as well. I think you'll find once you start having a worm farm on your house, on your property, you'll find worms pop up everywhere. They'll just gravitate to those fertility places. And I've read lots about worms in terms of how they turn a lot of toxic things into beautiful things too. So they're quite amazing in terms of their ability to, not only detoxify, but of course make nutrient far more readily available to plants too in that system. So that's a really important thing. At home here too, I've got a reed bed that, where the water goes through, but I've got a Clivus multrum, which is a dry composting system too. And again, the worms have gravitated there too. And you just need to manage like any compost system, your carbon, nitrogen, and a bulking agent, so that the urine, sometimes the urine is best to separate as well too, because you can deal with that in a much more productive way than once it's mixed with excrement, and then you have to try to separate those things too. So there's a whole range of issues there too. But no, I think there's a bit of extra work, and but the amount of water that you don't use, I think Roman mentioned 15%, but I reckon here it's almost 30% of the water would go through a regular, cistern toilet system. So
I have a slightly different way of treating it at home. At least for me, it's called wee on a tree. So that's
great fertilizer.
So I find a different tree out in the backyard and just go out there. Well, not when people are there, obviously, but and it's a bit disconcerting if I can hear somebody in the backyard next door. But that saves water when you're going out, because you're not flushing, and it provides nutrients, and that's where most of the nutrients are in the urine anyway. So even if you do things like that, and I know some people who do keep, some people think it's an unsavory subject, but keep it in buckets and then go out and do it. I'm not quite there that yet, but I'm quite happy to go down the backyard. And
it's a really powerful fertilizer though too. And I think you'll find the organic certifying bodies won't allow you to use urine. But I think if you mix it with like a high carbon material, like wood chips, then it's a beauty.
And if you're in the same spot all the time, it makes a difference too. But if you're going around, the only thing I have to do is, I'm down in my orchard area, is I have to kick the chooks away, or otherwise they come up and really interested. So that's a bit annoying as well. So the joys of sustainability, isn't it? So Roman and Margaret, have you got a comment on that?
All right. There is. Sorry. Okay, go on.
Roman first and Margaret.
With the bucket, I'm actually making the fertilizer in a way. I'm using wood ash and pink in that bucket, then diluted that, and it's the best fertilizer for tomatoes and bananas, whatever actually needs a lot of potassium, because in wood ash is about 10% of potassium, and they love it. But you have to dilute it, otherwise you burn it. The citrus trees, they absolutely would love you to be around them. In terms of composting toilets, as far as I know, I don't have experience with worms and so on, but using human manure from the composting toilets, you would be actually getting about 70% of your needs for garden fertilizer. So you are closing the loop, and you would need just a 30% top up of from other sources to kind of keep you going and eating, if you know what I mean.
Yeah,
Margaret?
you have to be careful that you don't eat antibiotics, dewormers, and this sort of
Yes.
stuff, because medicine will end up. There are 3 types of composting toilets, as far as I can think, and I was interested in this issue. First is a composting toilet which uses the air movement. So actually, you get a buildup of dry matter in your composting toilet, and it builds into a small volcano shape. So you need to basically remove it, and it's powdered already. So you can use it in compost. You can, mix it with water, with biochar and whatever. Then there are wet composting toilets when you mix some sort of high carbon material. So I've seen coffee chaff being used, and the very fine dried sawdust, but it has to be sawdust from pure wood, not from companies which make furniture, kitchen furniture from MDF or plywood because of the glues. And you add bacterial cultures to this. So such toilet does not smell, and you can basically shovel whatever is in there. You have to have access under the toilet to get it, and you can add it to compost, or you can spread it into your garden as top mulch. And then the third system, it's the worm toilet. And a friend of mine who built a straw bale house, they actually get all output from their home, which is gray water, laundry, kitchen water, and the toilet, into a big buried in the ground worm farm. And they've got, I think it's got 2 stages. One, it's sort of going through worms with some wood chip, and another is sort of the liquid stage. I don't remember what it is, but you can get something like that. And you can put it away from the house. It's buried in the ground. You just got, a thing which is basically aeration chimney, and that's it. And speaking about watering garden trees, I was just laughing because this is such a boy thing. I just got a bucket in my garden next to the compost with some wood chips in it or coffee chaff, and that's what I use when I'm in a garden. And in terms of the liquid output, I don't collect human manure, but I'm thinking about it. And if you use normal toilet at home, you can still reduce water usage. And you probably know the saying: if it's yellow, let it mellow. If it's brown, flush it down.
Exactly.
So you don't have to flush every time.
And it's been really interesting talking about composting toilets, that at more and more of the events that I'm going to, they're bringing in composting toilets and bringing in companies that actually do composting. And I was at the Off-Grid Living Festival earlier this year, and that whole event was managed and run sustainably, obviously, but they had a company that was actually profitable, providing composting toilets. So all of the material that was there in the toilets was being taken away to a composting station and being turned into fertilizer for general use on non-edibles and things. But so it's coming along more and more. I'm sure that we could actually have a complete a 4-hour seminar, a webinar on this just on itself, this topic as well. And people find, and it's quite interesting because people find it both fascinating and a bit sort of icky sort of thing. But it draws people in anyway, and there should be more of it.
Cultural. It's cultural.
It is
you
cultural,
just learn which things are icky and which are not.
Exactly.
For your parents when you are little.
Yeah, and as soon as you have kids, you very quickly get over it because you have to. And
I think the Victorian era has a lot to answer to, I think.
Well, yeah, I actually wrote a blog on that a while ago, not to sidetrack this discussion, and it was basically one of the big engineering achievements in the health services was back in the early 19th century when we did create sewage system, which was particularly important for large overpopulated cities of the day, which was London and right through Europe and through the subcontinent and India and everything, where you did have outbreaks of cholera and diseases and everything because of the poor sanitation systems. So getting that stuff under the ground and away from people and not having it sitting on the surface because it wasn't managed properly was a big deal. But it's come so far now that we now can't imagine bringing it back and actually starting to recycle it locally. And so we've got to sort of try and break away from that mindset. And it's happening, but it's just going to be a slow process, I think. Now we've got about.
If I could just continue talking about commercial use of human manure. As a child, about 40 years ago, in Poland, my dad used to manage sort of experimental government farms, something like ABARE or CSIRO. And I remember, because we were in a village, we were not on sewage system. We had septic tanks everywhere. They used to bring this, big cistern with a pump. They would pump our septic tanks, and then they would spread it on the fields, usually in autumn. Before winter, when the fields were fallow, they would till everything. They would plant lucerne or something like that, to add. So, it's not very long ago, it was still used in Europe. People would pump septic tanks and put everything on fields. And it would decompose, it would go through winter, they would put green manure on it. And then, and they also were doing crop rotation. So, it was amazing. Now I realize what it was.
Yeah, exactly. Yeah. So and still used in many other parts of the world. And this is the issue with it, is it's got to be done properly and in a safe way. And so if you actually do it in a safe way, it's fine. It's when you let it build up in cities and it just becomes too much of a problem to deal with in that way, that's what the issue is. Just running along with that theme too, we've got about 10 minutes to go, and running along with that theme was a few people said that what happens if you're constantly putting water, perhaps grey water, but even just rainwater and stuff into a bog drain garden? Does it start becoming, do you start actually sort of adding contaminants to it, because you've basically got a system where you've got water being used and then disappearing, but the metal, the materials that the water carried in are still there? So do you get a concentration of things like salts or heavy metals or pollution or anything coming off the water from the roof, for example, into those boggy areas where you've got a bog garden? So Margaret, I think that's probably one for you.
All right, you could do a few things. First, make sure that this water is pretty clean. So, for example, as I said, I only take rainwater and store it from the part of my roof which has got no lead flashing. So that's one thing. There is hardly enough pollution on the roof to warrant particular attention, unless you are living in heavy mining area or somewhere near chemical factories and stuff like that, which majority of people really don't. And the last one is you can actually test your soil. There is a free testing system. Actually, I think they ask for $20 donation, which is at the Macquarie University. It's called Veggie Safe program. And you can test up to 5 samples from your garden.
Okay.
So you can, and they test them for heavy metals, I think for about 30 heavy metals or something like that, some huge amount. So if you are concerned about it, you test it. You may also choose, if you see that you get contaminants in the water which goes to bog garden, then you don't plant edibles there. You just plant something that cleans water. And I've seen, I think it was on Gardening Australia, I've seen large commercial water cleaning. They were actually cleaning sewage using a system of ponds and reed beds, and that was on huge scale. So you definitely can use plants to clean the water.
Well, Werribee in Melbourne is in the western suburbs of Melbourne. There's a massive system like that in Werribee where we use the same. They use the same thing. It's a big open land area where they actually do that exact same treatment. And
maybe that's the one which I've seen on Gardening Australia. I saw it somewhere.
Yeah. And so related to that then is another question that came in. Do you think it's okay to directly irrigate your land, just having the water come straight from the downpipe with no storage or anything? So you're just basically diverting the water from the roof directly out onto the garden. Is that an easy thing to do, or a good thing, or are there special considerations that you should think? I might actually throw that first to Roman, and then maybe to Eric, and then back to Margaret for that question.
Yeah, what I would say is, again, you have to use a common sense. So if you're draining washing machine into the one spot all the time, obviously there will be buildup of negative stuff. So you want to kind of spread it around. And if you do this, then it should be fine, because the nature actually helps you to clean stuff, and especially when you don't using like a nasty detergents or anything like that in the household, then it shouldn't be that of concern.
And so what about water coming off the roof though? Instead of storing it in the rainwater tank or something where you just divert it straight out onto your garden or out into the area around the house, is what sort of considerations we need to take into account?
Okay, so what you would be adding is the contaminants from the roof to the garden. So it would be twice as much as if it's falling on the garden anyway. Right?
Exactly. If you have contaminants on the roof,
the burden wouldn't be that great.
Right. Okay. So what about in terms of do you have a problem with soil types, for example? Maybe throw back to Margaret for a start, and then we'll get Eric to finish this bit off. With different soil types, you said you're on brick clay virtually, Margaret, and that you've had to get the soil in much better condition so it soaks up water. So how do you manage that water runoff, and how do you determine, which is another question, the amount of water that you're getting coming from your roof, or coming from just from a rain event and everything? How do you determine what sort of water is actually landing on your land, and then how much comes off your roof and on top of that?
Well, what comes from my roof gets stored in rainwater tanks, and I mostly use it at home, not as much in the garden. But I don't really do much calculations, because I just get the statistics from the Bureau of Meteorology, from the nearest weather station, which is about 2 kilometers from me, which is pretty good. So in straight line. So for statistics, that's what I have. But from practice, I know that my garden can absorb any rainfall up to about 25 centimeters a day.
Wow, that's a lot of water.
Because I've got a lot of mulch, I've got swales, I've got plant cover, I've got the methods to slow the water runoff, so it actually soaks into the soil.
That's that much water over all your land. Yeah.
So I only get runoff after the first 25 centimeters.
Wow, that's a lot.
And I can see that the garden cannot absorb it, because I've got steep garden, which has got swales, mulch, and plants. Then I've got some footpath, which is straight, and I'm going to put little gutters in across the footpath, which will direct water into swales as well. That will slow the water too, going down the path. Then I have pretty flat area, which is lawn. And I've got a big sort of drainage pipe there, because if it rains really heavily and I'm over 25 centimeters, then this lawn, as I see it being converted into a pond, the excess water has to run off somewhere. So it ends in pipes. But I was talking centimeters, not millimeters, John.
Yeah. Centimeters.
That's 200. That's 250
millimeters, which is just amazing amount of water.
Yeah, but most of this water stays in the garden. And that's because the garden hasn't really, it's got only one straight path downhill. Otherwise, everything is horizontal. So very much the layout of the garden looks like a leaf. So it's got the main path, and then it's got paths coming out of it, like veins in a leaf, which also stops water. Added to this are the swales.
So it spreads out.
Yeah. So it stops the water because the paths and the swales are across the slope.
And Eric, what about you? Have you got any thoughts about diverting rainwater directly out onto the garden, or are you more of a fan of keeping in a tank and using it when it's needed?
No, I think I think Margaret mentioned this before that the best place to keep water is in the soil for lots of reasons, and indeed I think it's one of the greatest things that we overlook in Australia considerably, because Peter Andrews talks about that too. And in fact, he's not averse to dropping a log and allowing weeds to proliferate as long as you're collecting water, so that anything that slows water down. And you'll find, but you've got to do your homework a bit too and calculate, like what's the catchment for this area, and indeed what infiltration capacity have I got. But of course, the old swales thing, and indeed keyline, I think too, running swales just off the contour so that the water moves, but it moves very, very slowly, and all the sediment drops out, you get nutrient with it. And as time goes by, root systems get deeper. I mean, we could really build phenomenal amounts of soil by just increasing infiltration too. And I'm trying to convince the Rural Fire Service too, they show how we should manage those zones between wildfires and the built-up areas. Those areas should become saturation zones where we divert water and saturate those areas, and that'll lower the temperature and decrease the fire hazard too. So, but I will say too that the other thing I think you need to be careful of is sodium. Sodium is an element that I think you need to be a little bit careful of too. And it's because in a lot of the things that we, in your food products that we buy, they are very high in sodium. And so our bodies excrete, therefore, a lot of sodium. And so that's another issue that you need to keep aware. But if you just keep rotating it around, I knew people that just had a hose and they just leave it there for a few weeks and then move it on a few weeks. And I will here put in a big plug for biodiversity too. The more living things you can have in a given space, the more capacity there is to capture nutrients, water, pollutants, and all those sorts of things too.
I think that's a really. I was just about to ask everybody if they wanted to make one comment that would sort of wrap the whole thing up, and I think that was a perfect one from you, Eric, already. So well done for preempting me. That whole thing about biodiversity. And I did watch David Attenborough program the other night, which was Breaking Boundaries. And there was a big thing about water in there and about biodiversity and how everything's linked to everything else. And so one comment that I would make is that one of the other questions that I've seen quite often in other forums is people complaining that their soil isn't holding water, right? Or is a hydrophobic soils, not realizing it rained heaps last night and the soil's only wet this deep. You may not have a problem. And so when you point out to people that, yes, that rain yesterday, I looked it up on the bureau and there was like 5 millimeters fell. Well, that means you're only going to get 5 millimeters penetration of the water anyway, because that's all that fell. There was only 5 millimeters of water. So you have to get large rain events to actually get that water to infiltrate. Once it goes down there, it stays there and holds it. So start doing a little bit of background and saying, make sure that what you're doing is treating the condition that you think is there. So if you think your soil's hydrophobic, then one way to do it is to actually test it with a hose, with a watering bucket and everything, to see if it is really, or if it's just that rain you thought was a lot isn't necessarily that much. So Eric, that was a great way to finish on that one. Margaret, I'll get you to finish. Make one general comment. If you wanted people to take away anything at all on this presentation, what would it be? And then I'll get Roman to do the same.
Think about what you eat, because the biggest savings in our water and energy usage is the food we eat. So grow your food, even if it's just herbs in pots, and picking greens, because they are also very expensive per weight when you buy them from supermarket, and they often get wasted. And visit the Sustainable Table website, which also gives you some examples. So go vegetarian 3 times a week, 4 times a week. The less meat, the less water usage. So the diet affects our real water usage.
Excellent. And Roman?
Yeah, what I would say is use common sense. And don't
common sense that common though. Yeah.
Yeah, it seems to me that people are losing
permaculture
right?
common sense.
Yeah. And don't wait and start something. Yeah, because unless you live it, you don't know what is it like to really live it. It's such an enjoyable time and lifestyle and so on.
And be prepared to make mistakes. People are often very worried about trying something. Oh, what if I get it wrong? Well, then you'll learn from it. You'll do it right the next time. So
all the time.
Yeah, so that's one of the big things. So be prepared to make mistakes. Live your life now. Watch what you eat, right? Pay close attention to that, because that has the biggest impact on water usage generally, and biodiversity. Make sure you do everything you can to increase the biodiversity in your local area. and beyond, which is a really good permaculture principle as well. Look, thank you very much for all the presenters. Dennis, really just disappointing we couldn't get you on board because of the technical difficulties, but I'm sure we'll have another opportunity to hear that. So Margaret, Roman, Eric, thank you very, very much for your time this evening. It was brilliant. It was I learned a lot of stuff. I'm sure everybody else learned a lot of stuff. We're getting comments coming in, great presentations to all of you, and you all did fabulous work. There are a lot of questions that came in on the Q&A that we tried to blend together that we would have missed out a little bit. We apologize for those. So if there was a question that you didn't quite get the answer to, I'm sure we can actually do something about that later on. I'm sure Sophie and the rest of the team are right on that. And the key takeaway from this is water's really important. There are really good things we can do with water. They're not that difficult. So keep learning. So thank you again for everybody. Thank you everybody for coming in on the webinar. It was great to see all the questions coming in. I had a great time. I hope everyone else had a great time. Learned a lot of stuff. And thanks to the team in the background and Sophie and all the rest of the crew. Well done, guys. Take it away. We'll wrap it up there and we'll let Sophie. It was wonderful.
Awesome. Thank you so much, Michael. And thank you so much to everyone. It was a really amazing presentation tonight. We really had a great time and we hope everyone enjoyed it. I just wanted to let you know before you go, we have one more expert session this week on heating and cooling on Thursday. And then we have our full day of free sessions coming up this Sunday on 17th October, which is Sustainable House Day. So you can go to our website, sustainablehouseday.com, to see everything that's coming up and to register. And before I go, I just want to thank our sponsors and our council partners for helping to make this event possible. So thanks so much to everyone, and I hope you have a great evening.